All right, if you're a React developer, you have definitely been here. You're staring at your component, you're pretty sure your logic is right, but for some reason, it's using old data. You update your state, but inside of uEffect, it's like time is standing still. So today, we're going to finally get to the bottom of this common headache and figure out what is really going on.
You know, this question from Mark Erickson it nails it, doesn't it? We used to wrestle with the this keyword in class components, and now with hooks, we've kind of just traded that problem for a new one, the mystery of stale state. And today, we are going to solve that mystery.
So let's treat this like a real detective story. We've got a crime scene, our component. We've got a victim, our state, which isn't updating correctly. And we've got a very sneaky culprit that's making our code act in ways we just don't expect. First things first, we need to investigate the scene of the crime.
Okay, so picture this. You're building a chat app. You've got a useEffect that connects to the chat room and listens for new messages. Simple enough. Inside that listener, you check a piece of state is muted to see if you should play a sound. But here's the problem. The user clicks the mute button, the state updates, but the listener, it's stuck in the past. It still sees the old value of is muted from the very first render, the closure is stale, and your mute button is totally broken.
Now here's the twist. The real reason this is happening, it actually has nothing to do with React at all. Nope. The biggest clue to solving this case lies deep inside a fundamental concept of JavaScript itself. To crack this, we need to talk about JavaScript's incredible and sometimes kind of frustrating memory.
And the culprit's name, it's a closure. Now, the official definition sounds a little academic, I know, but the idea is actually pretty straightforward. A closure is just how a function remembers all the variables in the environment from where it was created. Think of it like a backpack that a function carries around with it, filled with everything it might need later.
And the thing is, you use closures constantly, probably without even realizing it. Anytime you define a function inside of another function, and that inner function reaches out to use a variable from the outer function, well, that right there, that's a closure in action. It's that connection, that ability for a function to see outside of its own little world.
So here is the most important idea to grasp. Think of creating a function like taking a picture. The camera doesn't just capture the function's code. It captions everything in the background too. All the variables in its scope at that exact moment in time. And here is the key. Once that photo is taken, it's frozen. It can't be changed. The values are locked in.
To really truly understand how this photograph causes our stale state bug, we need to go even deeper. We're going to do something kind of fun. We're going to build our own super simple version of useState from scratch. This will make everything click.
Okay, let's walk through this. Our first attempt over on the left looks reasonable. We've got an internal variable, _val, and we return a couple of functions to get and set it. This works because both of those functions form a closure. They both remember that _val. But, and this is the gotcha in the middle, the real useState returns the value directly. If we try that, we hit our bug. The value we get back is a snapshot, a photograph from the first render that never changes. So, the solution is the module pattern on the right. By wrapping our entire hook logic in an outer function, we create this persistent scope outside the render cycle where our state can live and actually be updated. And this is basically how React does it.
All right, now that we understand that functions are basically photographs of their scope, let's go back to our useEffect mystery. We're now armed with this knowledge of closures, and we can finally see why that dependency array puts us in such a tough spot.
And this table lays out the classic dilemma perfectly. On one hand, we can add isMuted to the dependency array. That works, sure, but then our effect reruns every single time the user mutes or unmutes. It disconnects from the chat server and reconnects just for a Boolean change. That is wildly inefficient. But, on the other hand, if we leave it out, our callback is a stale photograph, forever stuck with the initial value of isMuted. You're stuck between a rock and a hard place. So what do you do?
Well, for a long time, the answer involves some pretty clunky workarounds, usually with something called useRef. But today, we have a much more elegant, modern solution that's built right into React. It gives us the best of both worlds and solves this problem for good. So just as a quick reminder, here's our problem code. The useEffect only runs once because its dependency array is empty. This means the onMessage callback it creates is a snapshot from that initial render. The value of isMuted it captured will never, ever change.
And here it is, the fix. It's a hook called useEffectEvent. Look how clean this is. We just take the logic that needs the fresh data, our message handler, and we wrap it in useEffectEvents. This gives us a special function that is guaranteed to be stable, so it's not a dependency.
Now we can call it from inside our useEffect, and it will always see the very latest value of isMuted without ever forcing our effect to rerun.
So here's the magic behind it. useEffectEvent basically separates two different questions. The useEffect dependency array asks, when should this effect rerun? But the function from useEffectEvent answers a different question. What is the latest state I should read when I do run? By splitting these two jobs, we completely solve the stale closure problem with zero performance hit. It's beautiful.
Now I know this might all seem like some new React magic, but just like when we built our own useState, there's a simple, powerful JavaScript idea hiding underneath it all. So let's pull back the curtain one last time and completely demystify React hooks.
The big secret to how all of React hooks work, it's not some super complex, magical system that you could never understand. It's actually shockingly simple. It's not magic, it's just arrays.
Here's a simple way to think about it. For every component, React just keeps an array, let's call it hooks, and a simple counter, current hook. Every time your component renders, that counter gets reset to 0. The first time you call useState, React gives you the state from hook sub 0, and then bumps the counter up. The second useState gets the state from hook sub 1, and so on. And that is why the rules of hooks exist. You have to call them in the same order every time, because React is literally just depending on that order to find the right state in its array.
So the next time you run into some behavior in a framework that feels like magic, just remember this. Underneath all the fancy APIs, it's almost always just simple, fundamental programming concepts, like closures and arrays, doing all the real work. The real power isn't in just memorizing APIs, it's in understanding these core ideas. Now that you know the secret, what other magic can you demystify?